Okay, welcome to week 6. I love this week. This is where we start to modularize our programs even more. We get to develop code that's reusable. And so we're going to use a little bit of vocabulary here. You've heard me mention method. Sometimes I call them functions, procedures, subroutines. They're all the same. The general idea is that there's a subroutine. It's a section of code that is reusable, and it's defined in a separate place, and we can call it and give it the things that it needs to be able to execute and do its job for us. Probably the easiest way to get started understanding these things is to bring back an old example. I've renamed week 3.1 to W6.example. You'll probably remember this assignment. This is the assignment where we asked the user for a day of the week, its number, from 0 to 6, and then we figured out what day of the week that was, and then we asked for another number, and we added that to the current day, and we figured out what day of the week that was. And we were intentionally making you type it all out because we wanted to get you ready for this week. But before we go too far down this path, and we'll get here in just a second, I just wanted to let you know that this is nothing new, and you've been using methods since week 1. System.out.println, you might be thinking of it as a command to print things out, but what it really is println is a function or a method. I'm going to try to use the word method because that's what they're called in object-oriented terms. A method, println is a method on the system.out object. And in fact, out is a variable in the system class or the system object. And so system.out.println, we are actually calling a println method on some object that knows how to print stuff out. And the reason that we would make this code reusable is because it does the same set of steps every single time. And the only thing different is a variable that we can provide. So in the case of the println method, it's going to do the same thing every time. It's going to send whatever we give it out to the screen. And so the only thing different is the string that we give it to print out. Our main method also has been a method ever since the beginning. And so we've been writing a method ever since we started the class, and you've been doing it. So this isn't anything new that we're dealing with, but we're just going to teach you to understand what we've been working with all semester long anyway. So let's move on next to the purpose, why we would want to reuse the code. And hopefully this is obvious to you. When you look at this chunk of code, I've got this nice case statement of 7 cases, and I repeat the exact same logic a second time. And as a programmer, that just frustrates us. We should not have to repeat logic, and not just because we're lazy, which most of us are. It's because if you repeat it, that means if you have to fix a bug, you have to go fix the bug in multiple places, and who knows how many different places we might have this logic copied to. So we definitely want to modularize this logic and put it into one place so we only have to fix it once if there's ever something that needs to be fixed. So we're going to do that now. Let's just take a quick tour through the program again and refamiliarize ourselves with it, and then we'll get on to making this a little more modular. So our program starts, and we're going to create a scanner for our user input, and then we're going to prompt for the user and ask them to enter in the day of the week, 0 for Sunday, 6 for Saturday, and we're going to read in the value. We're going to do some validation on it. It's got to be a number between 0 and 6, and if it's not, then it's an error. And then we're going to enter the number of days in the future, and we're going to read that from the scanner. We're going to double check that they didn't enter a negative number. And if they did, then that's also an error, and we bail out. And now we're just going to decode the day and turn the number of the day into the name of the day. And in week 3 in the code samples, I already posted an example of this, so this hopefully is familiar to you, of making this reusable logic. And we've also talked about, because the cases are consecutive integers like this with 0, 1, 2, 3 through 6, we can actually even use an array to speed things up a little bit even more. But for this example, we're going to be extracting this code and turning it into a method so that we don't have to list it twice. And so, you know, we decode the days, we do the math, and we add the future days, and we mod 7 to turn it back into a day of the week with between our 0 to 6, and we decode it again, and then we print out the results. So hopefully that is familiar to you, and hopefully that brings back happy memories. If not, maybe this will make it a happier memory. Okay, so let's look really quickly at this logic. And I'm trying to think if there's an easier way to look at it. Probably not. We'll just look. We start off with switch on today, and then we just say if case 0, then the weekday today is Sunday. If it's 1, the weekday today is Monday. So we're setting the weekday today, and the value is going to be the same. And so if I look down at the next switch statement, I have a slightly different value going into the switch, and I'm setting a different variable, but the values are all the same. And so I look at this, and this is identical code, and the only thing that's different is the value that we put into it and the value, like weekday today or weekday future, that we get out of it. And so when you see code like that, where everything's the same except for the inputs and the outputs, then that's a prime candidate to modularize into a separate method that we can reuse and call multiple times. So let's do that. Let's come down below. And so we can see right here, we can't define a method within a method in the classic sense of the word. So we want to make sure that we're outside of main. And so we'll scroll down here, and we can make sure that we're outside of main just by, we've got that highlight there, and now we're just inside of our class scope, which is the outermost curly braces. So I can say private. We're not going to worry too much about private. And actually, let me give you a template for the method definition. So there's something, every method has something called a signature. The method signature is the method name and the parameter list. And the parameter list is defined as the type of variables. So that's our generic form. And in Java, we can specialize this to, we've got modifiers. That's what the public and the static are going to be. And I'm going to put those in square braces. That's usually the indication that those are optional. And then we're going to have the return type. The return type is not technically part of the signature. It depends on who you ask in the computing field, whether they think that's true or not. You'll get different answers. But in the case of our textbook and the question that's going to be on the quiz during week 6, the return type is not part of the method signature. But then we have the modifiers that are optional, a mandatory return type, a method name, and then in parentheses, the parameter list. So that is the method signature. And the return types are just going to be the different variable types or data types that we have available in Java. Float, double, string, int, jar, boolean, etc. When we get to classes and objects in a couple of weeks, we'll learn that those are just complex types that are built up on top of and made up of the primitive types. So you can return a class as well, but the return type is something that we have to declare. And if a method does not have a return type at all, then if it doesn't return any value, then the return type will be void. And we can see that here in main. Our main method never actually returns a value. We've seen a return statement, but we've never given it a value to return. So main is void. Main just executes, and when it's done, it's done. And there's no value that comes out of main unless we call system.exit, but that's actually giving the exit code to some other thing in the Java system that's going to take that and return back to Windows or Linux or Mac OS when the program is done. But in our case, main has never returned anything, so it's void. Now, public and static have to do with object-oriented stuff, and we're just going to take those for what they are. In this week's assignment, your methods are going to be static because your main is static, and you'll understand why in about 2 weeks. And public, you can either make them public or private. It doesn't matter to me. They'll be able to be called from within our class this week anyway. Public generally means that a class other than W6.example could have access and call that method. Private means that nobody else, no other code can see that code except code that's defined within our class ourselves, within the same file. Okay, so we've looked at our method signature, which is the method name and the parameter list. So this is the signature. And then I'll say the declaration of the method includes the modifiers and its signature. Modifiers, the return type, and its signature. So to declare a method, we need to declare the return type. So we're going to say void, but in our case, we want to return the name of the day. So that's a string in our logic up here. So we're gonna come back here and we're going to return a string. So this is our return type. And then we're going to say get day of week is our method name. And remember, we said the only thing that's really different is the value that we're doing our logic based on, what our switch statement is based on. So we just need to have a variable in this code that will that we could use in the switch statement, and then we could provide whatever value we want to as that variable. But we need to give that variable a name. So we're going to say it's going to be an int, and we're going to call it day number. Okay, so now I've got a method named day of week, and it's going to take in its parameter list is a day number, and its type is integer. And this Java will enforce this. We can't ever call day of week unless we provide it an integer. And to fill this out, to make sure that we can call it from our main method, we're going to make it static. And just for completeness, I'm going to, because my brain will look at that and say, I have to have another modifier to say whether it's public or private. So I'm going to make sure that it's private. And that just keeps it so that no other code ever could call it except code within our own W6.example class. And you'll see here, and this is something important because you're going to notice this when you start doing your own work on this week, is I have a little error indicator down here. It's hard to see because it's an error under the closing brace. If I hover over it, then it's going to say missing return statement. So I've actually said that day of week is going to return a string. And so IntelliJ is saying this method is supposed to return a string and you're not returning anything. You'll see if I change this to void, then the error goes away because now IntelliJ says, oh, it's a void method. I'm not looking for anything to be returned. We're going to return a string. So to get that error to go away, I can simply do a return an empty string like that, and that takes care of the error for now. This is not how our code is going to finish, though. So I've got my parameters, and the best way to think about parameters is that they become variables inside of your code or inside of your method. So there are different types of variables that we've seen. We have local variables, and those are variables that we've been working with all along, all semester long. These are the variables we define in our main method. So any variable defined within a method is called a local variable, and its scope is limited to the method that it's defined in. And technically, it's limited to the curly braces that it's defined in. And so that would be a local variable. The next step up would be a parameter, which its value comes in from outside the method, but then it looks like a local variable for all intents and purposes inside of the method. And then we also have class variables, and we don't have an example in this one, but a class variable would be defined within the class, but outside of any method. And all methods in the class have access to that variable. We'll see that again in week 8. But if we look at this now, I think we're ready to start implementing this logic. So I have my day number, And I'm simply going to grab this code here, because as programmers, we're basically lazy. It's not really laziness, but we want to be very efficient, and the code's already been written. Why duplicate it, right? So I've got my switch statement. Looks like I'm missing the closing brace. And I have this string weekday future. Now the name weekday future doesn't really mean anything anymore, because day of week doesn't know whether we're asking for the future day or for the current day. We're just asking it, given this day number, what day of the week is that? So we can just call it weekday name, and that makes it very clear. Because remember, we're going to call it from out here, and we'll come back to this point, but day of week has no idea what type of, what the context is that it's being called from. All it knows is if you give it an int, it'll give you a weekday name for that int. So I can change weekday name. In fact, I'm going to illustrate something here. We had weekday future. Here's a nice little feature of IntelliJ, and Visual Studio Code has a very similar feature. If I right click on this and I choose refactor and rename, it will let me type a new name. I'm going to change the name to weekday name, and you'll see that it changed it everywhere else that variable existed. And since this variable only exists within this method, then we don't have to worry about accidentally coming up here and changing weekday future out here. So let's pause for a second before I hit enter and ask, why did weekday future out here not get affected? And the reason is, even though it has the same name, it's a different variable. It exists in a different scope. So the scope of weekday future it's defined within our main method. It's defined within the curly braces of the main method. So it belongs to the main method. When we get down here to the bottom of our main method right here and our method ends, then this weekday future variable just evaporates. It goes away. It doesn't exist anymore outside of the scope of the method. And so when we start a new method, we're free to create another local variable of the same name. And it's a totally different variable, even though it has the same name. Sometimes that can be confusing, so you still want to be specific about what things are used for. But when we changed the name weekday future to weekday name, this weekday future up here is not the same as the weekday future that was down here defined in the method. Different scopes. That's important. That shows up on the quiz this week. So when we're done refactoring, we'll just hit enter, and IntelliJ will actually go and make the change for us. So that's cool. And then whatever we set weekday name to, whoops, we're going to return the value of weekday name. Now we've just got this one little bit inside our switch. Remember, the only thing that's different about this logic is the thing we're switching on, the value we're switching on. And in this case, we've said that we want the user to tell us the day number they want us to decode for them. And so that is a parameter of our method. And we use it as if it was a local variable inside of our method. So another question that comes up, and I'm giving all sorts of things. If you're paying attention, you're getting these on the test. When you're defining a method, we technically call these the formal parameters. When you're calling a method and providing the value, then we call those actual parameters. I will tell you that only matters to academic professors. In the professional world, we don't make that distinction. We call them arguments or parameters interchangeably. We use those as synonyms, arguments or parameters. But we don't care whether the professors call them formal or actual, honestly. And so I wouldn't worry about that. Well, I would worry about it this week when you take the test, because there's a question on the test about it. So let's read through this code now. What we've got is get day of week. We pass in our day number. We're going to do some logic on our day number. And let's just see if our logic works. So if the day number comes in and it's not a valid number from 0 to 6, based on this logic, we get down to the bottom. So I've already provided a default value for weekday name, so I don't really need a default case down here. I could have one, it would be fine. But we're just going to return null if the day number is invalid. And maybe that's not the best thing to do, because what does null mean? Null is the value of a string that has no value. It's technically the value of an object, and strings are objects. So let's do this. Let's add a default case, and we'll set weekday name to invalid day number. And that will get returned, and then when we go to print out the value to the screen, we'll get to see that the invalid day number. Now, it's not, this line of code should probably never get executed, because we've already got logic built into our program to check that the user entered a valid value. So we're going to be okay with that, but just for the sake of completeness, I'll make sure that this method handles any case that we could throw at it. So that's our method. Maybe a little bit of extra white space just to make it a little bit readable here. And then one other thing to note about methods is, and I'm requiring this, from this point on, I think you know enough now to decide whether you need to have a description comment at the top of the file. Sometimes it's very clear what the file does, and sometimes you might want to have a description. So I'm not going to harp on that anymore, because I want to shift my focus to every time you define a method now in your code, separate from your main method, you must have a documentation comment on it. You must have at least a comment that says, this is what this method does. Now, I like to use the documentation style, the /**, which turns out to be the Java doc format, because IntelliJ it uses a template and it fills a bunch of stuff in for us. So then it puts a cursor right there, and I can say, all I did is type /** and hit enter, and IntelliJ fills in this snippet for me. So I'm going to say, decode the name of a day of the week given its day number. So the parameter is the day number, and then I can add a little comment here that says the number of the day 0 to 6, and it returns the name of the day, and the Java doc will make it very clear that we're going to return a string, and that fact is available right here. So that rounds out our method. And now let's see what this does to our code up above. So look at how long this main method is. It starts on line 22, and it goes all the way down to line 104. So if I'm doing the math, that's about 82 lines of code. And we're taking up quite a bit right here in our duplicated logic. But we're about to wipe this stuff out, because now that we have a method that does this logic for us, I don't need to repeat it up here. So let's take a look and see. We're going to say, well, I've already got my variable for string weekday name, and now I just have to set it to the value that's returned by our method called get day of week. Get day of week. Look at that. Oh, I have an error, and I did that on purpose. I have an error, and the error is going to say, no, that's offering to fix it, and none of those helps. Expected 1 arguments, but found 0. So IntelliJ is saying, hey, you've defined the get day of week method that it has to have a day number parameter in it. So you have to provide a value. So the value I'm going to provide is going to be the variable today. So remember, today is the value that the user entered. And we got that value from the user by calling nextInt on our scanner. So it's an int. And so that is all I have to do now to call my logic. And I can get rid of all of this code. So that's pretty cool, right? And then we'll get rid of that comment in there, and let's do the same thing. We're going to call get day of week, and we're going to pass in our today plus future mod 7. And I'll talk about these parameters in just a second. Look at that. we turned an 82-line file into a 30-line file. 33-line, sorry, an 82-line method into a 33-line method. We just got rid of almost 50 lines of code and replaced it with some nicely spaced, white-spaced 30 lines of code right here. How did we end up? Well, we've got some boilerplate stuff here. Okay. So that is our first method. Now you'll notice I'm passing in a variable, and you can pass in constant values. I could pass in 0 and that would be fine. Let's undo so I get my program back. I can pass in the result of an expression. And really, the expression is kind of at the heart of everything in a programming language, and this is not specific to Java. The expression is anything that leaves a value for the program to use in whatever way it needs to. So anything that leaves a value is an expression. So a variable is itself the value that gets left. In the next line, we have a calculation that leaves its result is a value. And in fact, calling a method right here is another expression, and it leaves a value because the value is returned right here, get day of week. It leaves a value. So get day of week is also an expression, and the value that it leaves is assigned to the variable on this side. Now let's prove to ourselves that our code works. So I'm going to run our program here. We'll let it compile. Okay. Given today's day of the week, we're going to type in 5. 5 should be Friday, if I'm doing my math right. And we're going to go 3 days into the future, and that should be Monday. So let's take a look. Let's try it out and see. Today's Friday, and the future day is Monday. Yay! So we just covered a weekend. So that's really cool. So I'm going to now fire this up in the debugger, and I want to show you a couple of things about stepping into functions and also about what's actually going on when we're calling a method. There's an area of memory called a stack, and it has to do with how methods are called and how we know where to come back to when the method is done, and what to do with the values that go into the method and that come out of the method. So I'm going to put a breakpoint right here. And just in case I hit the wrong button, I'm going to put a breakpoint down in my method so that we stop there. And now we're going to start the debugger. And there's some really neat things that the debugger will tell us. And I just want to make sure we're here in the debugger window. And our program is currently waiting on the input. So those of you who are used to the debugger already know that when you're waiting for input, the debugger is going to sit there and not let you pass that point. So we're going to enter in our 5 for Friday, and then we're going to enter in our 3 for the days into the future. And we have, now we're at our breakpoint. And so we've been in the console, we can see we've entered our data. In the debugger now, we see things that are familiar, like today is 5 and future is 3. Those are the variables that we created up here. So that shouldn't be any surprise to us. We know what our scanner is. We know that argv are the parameters that get passed into main if we provided any parameters on our command line when we started our program, which we don't do in our class, but a Java program has that ability. So all we have now is our 2 variables, today and the future, and we're about to pass today into the get day of week to figure out what the day name is for the value entered in to today. And before I click the next button, I want to highlight over here the frames. So our stack A stack is a structure in memory in a computer that builds on top of itself. So you build a stack up or down depending on how the computer wants to represent it. But the next frame goes on top of, or next after the previous one. But then when you unwind the stack, you actually, so you push things on a stack and then you pop them off the stack. And the first one in is the last one out. The last one in is the first one out. And we'll see that in action in just a minute. But why the stack is important is because when we call a method, the computer actually puts the data about the method call onto a stack in a stack frame. And what we'll see is that the reference to the method goes on the stack frame, and any variables that you pass into the method go on the stack frame, and then all of the local variables that are defined inside of the method go on the stack frame. So when I step into this method, get day of week, I'm going to hit the step into button now. Then we go into our weekday name, and you'll look right here, our main method has been pushed down. So we've actually pushed a new method onto the top of the stack, our get day of week. And you'll notice that it's got some interesting information about where we're at. We're actually, our stack is saying we're on line 70 in get day of week. And get day of week was actually called by main at line 48. So you can click on each of these stack frames and the debugger will take you to that point. So we could see here that main is sitting here waiting for get day of week to return. We've called it on line 48. So now we're on get day of week line 70, and we can then step through. And so the stack frame doesn't show everything that's on the stack, but just for your own benefit, the day number 5, is a variable that value number 5 came from out here, right? So that value 5 was actually today's value, or today being our variable that is out in our main method. So today is a local variable in main. We pass it into another method, get day of week, and that method comes through as day number. Now this is an important thing. This is in Java, our primitive data types are passed by value. So what that means is the value in the variable today, a copy of that value is pushed onto the stack with the method call. And then when the method is done, that value disappears. And so whatever today is, today doesn't, this value won't ever change because what we passed into get day of week is actually a copy of it. So we copied it from the memory space of our main method into the stack as a new value, and it takes the name day number, and it gets used as a local variable here. And I'm going to modify the code in just a second to illustrate this point. But we're just going to watch it work here. So we're going to execute, and we did a switch already on the day number variable. We found it was a 5, so we're going to hop down to number 5. We set weekday name equal to Friday, and then we break out of our switch statement, and then we return weekday name. And weekday name is also a variable listed in our stack frame here, but the return value actually gets put in a special spot on the stack so that it's available as an expression result in the method that called it. So when we return at this point, then we go back to weekday today, right to the point where we started, and then we'll step over that line. And now we see that weekday today got the value of Friday. So our get day of week, the method call was an expression because it returns a value. It was an expression, and we copied that returned value off of the stack when the stack came down, and we put it into weekday today. So you'll see that our get day of week disappeared from our stack, and now we're just back in main. So everything, all of the memory, all of the variables that were working for us in our get weekday name, they're gone. They just evaporate. They don't exist anywhere. So we're going to now call the next get day of week, but before we call it, we're going to actually implement, the computer is going to do this calculation for us, because in the order of operations, calculations inside of parentheses get done first. So inside of the parentheses of our method, we're going to actually calculate this expression, and its result will become the variable or the value that we copy to our stack, and that becomes a local variable in our next method call. So if I go down here, we'll see that day number is 1 because up here, if I go back to main up here, 5 plus 3 is 8, mod 7 is 1. So 1 is the result of this expression, and that's what got passed into our method. So get day of week now has the value 1 as day number, and we're going to step through our code, and we'll see that we get Monday, and then we're going to return Monday. And now we have our weekday today is Friday, and our weekday future is Monday. And I'm just going to hit the go button and run the rest of the program. And voila, we got our output. Today is Friday, and the future day is Monday. So you've now seen stack frames. That's probably going to be a concept that you're going to ask about during the week, and I think that's a good idea. You do not have to understand stack frames and how they work at the very details that I've described here. There is a question about stacks on the test, and so in your studying for the test in the chapter, you probably want to pay attention to what stacks are and how they're explained there. But you don't have to worry about how the memory works or anything like that. You just have to understand that a method call pushes stuff on the stack, and then when the method returns, that frame of the stack is wiped out. Okay, I did promise that I would show you what pass by value sort of looks like. So I'm going to set day number. There's no law that says I can't change the value of day number here. I'm going to set day number equal to 0. So day number is going to get passed in here, and I don't care what they pass in. I'm going to override it and set it to 0. And then we'll get the whatever results. But I wanted to illustrate this point. So let's debug our program again. And what the point we're going to illustrate is passing by value. And some people will call it pass by copy. And that's probably a little more descriptive of what's going on. So I'm going to say 5 and 3 to keep our example the same. So you'll see here, today's value is 5. And when we step into our method now, we get day of week on our stack. So we push the day of week onto our stack. And our day number becomes, it's 5. And if I come back out here, I look, and today is still 5. That's fine. That's what we would expect. But if I execute the line of code that sets day number to 0, you'll see here, day number now equals 0. But if I come out to main, my today is still 5. And that's because I didn't actually pass today onto my stack. I passed a copy of the value of today onto my stack. It's actually 2 different places in memory right now. So our original today is safe. I can do anything I want to mess up the variable inside my method. It doesn't mess up the variable outside the method. Now that only works with our primitive types. With our complex types like strings, arrays, and objects, when we get to week 8, then things are a little bit different, and we'll talk about that when we get there. But just so you can see here, pass by copy means that the outside value is safe from whatever happens on the inside. So we'll see here, and our logic comes back. So no matter what, we passed in a 5 and we got a Sunday, and that's because we have a big whopper of a bug in our code right here. And that can actually cause some trouble for you when you are debugging code. If you're not understanding what's going on between pass by value and pass by reference, which is the way that strings and objects go in. But that should illustrate the point. So we'll just continue on, and it looks like you'll see in our output here, oops, we hit that other breakpoint, so we'll continue on out of there. And we say today is Sunday and the future day is Sunday. And that's because we didn't care what the user typed in, we just set everything to 0. So we'll get rid of that line of code. And then our code works nicely again. So that's nifty. And we could probably end the demonstration here. But I want to push this to the next level and challenge your thinking a little bit. So I've got here on the screen, I'm going to ask you to pause the video in just a moment. I've got here on the screen another opportunity for making some code, some common code into a method. And so I want you to pause the video here and look at the screen and see if you can see what the common code is that might be able to be extracted to a method. So go ahead and pause. All right, hopefully you paused and took advantage of this little learning opportunity. If you'll notice, we've got this little bit of information here. We have a prompt of some sort, and then we have a scanner.nextInt. And then I come down here, I do some validation on it. I come down here, and I've got another prompt, and I've got another scanner.nextInt. And I'm just grabbing the value from scanner and assigning it to my variables. That's actually an opportunity to do some more common code. So let's go see what the common code might be. Let's see, I want to have, we're gonna say private static, we'll get those modifiers out of the way. We're gonna get an int because we're gonna prompt for the value and we're going to get an int back. And we're gonna say prompt for int is the name of our method. And what do we need actually to be able to prompt? Well, we need the string that we want to prompt the user with. We also need the scanner object. And I will tell you that it's actually easier to declare your scanner outside of your method and pass it in than it will be to create your scanner inside the method. And part of that is because some of you have seen that if you create a scanner based on system.in and you forget to close it, if you try to create another scanner based on system.in, on some computer environments, it will crash your program. So it's better to be in control of your scanner and then just pass it in where you need it. So we're going to pass in our scanner. So we need that as a local variable in our prompt for int. So we'll call it scanner. And then we need the prompt, the string we're going to print out. So we're going to say string prompt. And then we're going to actually do a system. So here's the common code up here, right? So let's just grab this common code. We'll make a copy of it here. And we'll paste it in here. So system.out.print. Now we don't have a hard-coded string here because we have no idea what the string is. And it's going to be different depending on who calls us and when. So we're going to print out our prompt. Our prompt is a string variable that got passed in. And our scanner is going to read in the next int. Now, we don't have to assign it to the value today because we don't know what name the variable is going to take, right? So we could say int value equals scanner.next. We can be, and so scanner.nextInt actually returns, it's an expression because method calls that return things are expressions, and it returns a value. So it provides a value, or I guess the words I used a little earlier, it leaves a value when it's done executing. So scanner.nextInt will execute, and then it will leave a value in its place that will be used in the next outer expression, which the next outer expression is assigning it to the variable value. I don't actually have to assign it to a variable. I could just return it, because return lets you return the value of an expression. So scanner.nextInt is going to leave a value right here, and the return statement is going to pick up that value and return from the method with it. So that's all we have to do. Let's add our documentation, /*, hit enter. We're going to prompt the user for an integer value. Scanner, the scanner object to read from, prompt the message to print to the user as the prompt. And it's going to return the integer value read from the user. A little bit of a typo there. You've seen my code all semester. You know that I'm full of typos while I type. Hopefully I catch most of them, but probably not as many as I think I catch. All right, so this is a well-formed function, and again, we see the format of our function definition, our declaration. We have our modifiers here, we have our return type, and then we have our method signature, which is the name of the method and the list of the types of parameters. So our method signature is prompt for int, scanner, string. And our method declaration is private static int, prompt for int, scanner, scanner, string prompt. So all we have to do up here now is use our new method. So we can say prompt for int. So we just use the name of the method. To call a method, you simply use the method name and you pass the required parameters. So we're going to pass in our scanner, and that's our variable up here, you'll see. And then we're going to pass in our prompt string. And we enclose those in parentheses with a semicolon at the end. And that's kind of a little bit of a long line, and sometimes you'll see us will actually put our parameters, if there's multiple parameters and it's going to make the line of code really long, we'll just put them on separate lines. So now we can just say today equals prompt for int, and then we'll do our validation on today, and then we'll do our future also is prompt for int. We'll pass the scanner and our string here. Now you'll notice when you start calling methods, you'll see a little word here. It says prompt, status, prompt. This is IntelliJ giving us a little help. It says, oh, this string that you're passing in, this is the prompt parameter, and it corresponds to the name of the parameter down here, prompt. So this is not actually part of Java. This is just IntelliJ trying to be helpful. So you may be confused by that if you're using IntelliJ. Visual Studio Code does not do that for us. It's a very helpful tool for professional programmers. I found that for students, it kind of makes it a little bit harder. And so I'm going to invite you to go into the IntelliJ settings on your computer and find where you can enable or disable parameter labels or argument labels, and see if you can find it. Kind of a little scavenger hunt. If you need a little bit of a break and you need a brain break, go ahead and take that challenge and see if you can find the settings. And if you do, see who can be the first one to post it to a discussion board. All right, so we've actually abstracted, and that's a good word, we've abstracted this complex logic and this procedural code here into a simple name. That's all a method does, is it allows us to take something complex and give it a simple name and what it needs to execute, and it will return a value to us. So now our code is even more concise. Our main is simply prompt for int, validate what they gave us, prompt for int, validate it, and then decode the days of the week and print out our stuff. And that's really it. So there's one other thing I want to mention, and it's a term called method overloading. In Java, you can have two methods in the same scope that have the same name, but they would still have to have a different signature overall. So for example, and I think probably the best way to illustrate this is to use something we've already used. System.out.println. Let's take a quick look at how that works. And we're going to understand method overloading when we get into classes and objects in a couple of weeks. But let's define a little method down here, private static void. We're not going to return anything because I'm just going to show you this and then delete this from the example. Private static void show overloading. So I can say system.out.println. Look at all the different println methods we've got. We've got a println that takes an int, another one that takes a char, another one that takes a long, another one that takes all of our basic primitive data types, and then they take strings and objects as well. And then there's an empty println. So if you look at this, these are all the method's signatures right here. So print line, there's a version of print line or an overload of print line that takes an int. And there's an overload that takes a char. And so you'll see, even though you can have multiple methods of the same, of the same name, they all have different signatures, and that's what matters. So in Java, a method has to have a unique signature, but it does not have to have a unique name. So if the parameter list is different, then the method is actually a different method. So that should help you. And that's operator overloading, or method overloading, sorry. I slipped back into my C++ world there for a second. Okay, I think that's good. I will tease you a little bit. Unfortunately, this is a basic Java class, and so we won't get into the next form of methods where you could actually pass a whole method body as a parameter to another method. We call that a lambda form. But I'm looking at this validator, and I'm also seeing common code. I do an if check on some condition, and then I print out some error message and I exit. I could actually create a method that would allow me to pass in this condition, the string, the message I want to print if the condition is true, and the error code I want to exit with. I'm not going to show you how to do that because passing in a method that's a little more involved, there's a little bit of work to set it up. But once it works really elegantly. That's a level of abstraction that we won't get to. If you want to read further in the book, you'll be able to, if you talk about lambdas, if you look up how lambdas are used in the book, it'll take you into the future chapters. And I think it's in the book. I think it's in the future chapters. But if not, it's definitely part of Java 8 and newer. And we use those things all the time in professional code. So I think what I'll do is I will end the video at this point with this example, and I'll post this example, and then I'll cook up the example that lets me abstract away my validation. And then you'll see that this main method just becomes super simple, and all the complexity of the code is abstracted away into nice named methods. Oh, and one more point. Please give your methods a name that describes what they do. Don't call it M1 or anything like that nobody would understand what it is. Just give it a nice descriptive name. It doesn't cost anything extra in your day to include the vowels. There's no glory in having super short variable names anymore in programming. So don't do that to yourself or to your coworkers. But I think that's it. That's enough soapbox. So I will post this to the code samples, the week 6 code samples as our example. And for our office hours, we will have a drop-in office hour on Wednesday for you to come in and ask any questions. We won't be doing an example that night. This is the example we would have done. And I'll just be available Wednesday night for whatever questions you might have. So drop in and ask them, or ask them in the discussion board, and we'll take care of them. Thank you. Make it a great week. Do not let the exam stress you out. This is going to be a good week for you. It's an exciting week. We get to elevate ourselves as programmers even more. Take care.